Hey guys, welcome to this lecture. So today we will do the basic configuration so that this particular machine right here can communicate over internet. So this is like in the previous video we have seen that how you can configure the management interface and you can get the GUI access of the firewall, and then you how much basic configuration is required to bring up your network. I mean, your machines can communicate over internet through a firewall. So, uh, if you will see, this is the console access of this particular machine, and if I will try to ping internet right now, so you will see that it will time out, right? So this machine is not having internet access, and if I will try to check the configuration, so the gateway is 10.2.2.1. So let me just ping the gateway 10.2.2.1, and you will see this gateway is also not reachable. So this is the gateway IP address 10.2.2.1, which is configured on the Ethernet 1 by 2 interface of this firewall, right? And this is the outside IP 10.1.1.3, which will provide us the internet access. So this is the basic configuration we need to do as per the topology so that this machine can reach the gateway, and then this Palo Alto VM can do the processing on that particular packet, and then it can send it out over the internet. So this is the web UI of the firewall. So first we will do the basic configuration. So let's go to the network, and inside network you will have interfaces. So Ethernet 1 by 1 is going to be the outside interface, and 10.1.1.3 is going to be our IP address, and gateway is 10.1.1.1, right? So let's select the interface, and you can mention this is outside interface. Interface type is going to be the L3. Virtual router, we don't have any router, so let's click on the virtual router and let's create the router. So we'll create it default, and you can add the interfaces. So right now there is no interface configured, so we will add it later on. So you can delete this and you can just click OK. And security zone, you can create the security zone. So this is going to be the untrust zone. Logging setting, yeah, we need to log. So right now log forwarding is not configured, so we will cover this part later on. Type is L3, and you need to add the interfaces to the zone. So right now we don't have. Automatically it will be applied to the interface because we are configuring it from the interface, right? You can directly create the zones as well, or you can create it when you're first time assigning IP addresses to your interfaces. Then zone protection profile, we will discuss it later on. Enable packet buffer protection, user identification, device ID, ACL, right? And exclude list from user ID and device ID. These are the things which we will discuss later on. So let's do one thing. Let me just minimize. Yeah, so okay. So virtual router is default, security zone is untrust, IP address. So we are going to give static IP. You have this PPOE and DSCP client option as well, right? And you can enable the SD-WAN if you have the license. So click on add, and let's define the IP 10.1.1.3/24, and IPv6 if you have, you can configure SD-WAN interface. If license is there, you can configure the SD-WAN. And in advance, you can define the link speed, duplex, right? And management profile, if you have any management profile, let's say you want to allow ping on this particular profile. So this profile I have already created. So you can click here, management profile, you can give it a name, and you can allow the network services and administrative services on that particular interface, and you can create the permitted IP which can access those services on this particular interface, right? So generally in outside interface, we do not recommend to allow services like HTTP, HTTPS, Telnet or SSH, right? Because this is going to be the public facing internet. In my lab topology, you might get confused that we are using the private IP here, But in production environment, you will see that customers will use public IP directly configured on the outside interface. Since this is the virtual environment, so it makes sense, right? With this gateway is going to be the firewall, actual physical firewall, where this entire topology is becoming LAN to that firewall. And on the WAN interface of that particular firewall, we have the actual public IP configured, right? So do not get confused why I have configured the private IP. Just to give you the feel of the real-time scenario, how it works, and to make this EVE-NG topology to communicate with the outside world. This is the arrangement we have done. Okay. So now you can configure ARP entries. I mean, we will cover these entries later on, right? So in this video, we are just going to cover up the basic things. Then you can define the MTU if you would like to define the MTU, and you can also adjust the TCP MSS, right? Okay, so this is the basic configuration required. So our outside interface is configured. Now let's configure our inside interface. This is going to be the LAN side interface, which will become the gateway to this entire subnet. So you can call it out inside interface. Interface type is going to be a layer 3 and virtual router. So make sure that you are placing these interfaces in the correct router. So what happens in these firewalls, you can create multiple routers and you can attach different interfaces to these routers, right? And accordingly your routing will work. So we will discuss this in detail when we are going to create the virtual systems VSS, that how different routers, different VCs, can communicate. Then security zone, so we will create a new zone, that is our trust zone, because this is the LAN side of our firewall. And rest of the things we will keep it like that. Let me just, okay. And then IPv4, so IPv4 is going to be 10.2.1/24, and rest of the things will remain same. And if you want to allow the ping on this particular profile, so you can apply it, this already created management profile, right? So our interface is done. And if you will see zones, these zones are automatically created. If you want to create any other zone, you can click add here. You can give it a name, let's say DMZ zone, which we will use it for our future. Tap your DMZ zone type is layer 3. It means you can add layer 3 interfaces, and you can add the interfaces, whatever interfaces are available. Okay. So this you can do. Okay. So this you can do. Okay. So we will assign the interface later on. So now go to your virtual router, and here you can see we have this default router which we have created, and by default these two interfaces are added here. So let's add the static route, because we need to add the static route so that your entire LAN traffic can hit the box, and from there it has the default route which says that you need to break out to the you need to go to the next hop, and then next hop will take it over to internet. So I will give it a name, default route, and my destination is going to be 0.0.0/0, means internet, and interface is one by one. So as per the topology, this is our interface. And next hop IP address, so this is going to be the gateway IP address. So basically what we are telling this firewall that whatever subnet traffic you are receiving, destination IP address could be anything, you need to send it to the next hop, which is this, and then next hop will take it care. So click OK. This is the default route for internet we add. Now you need to go to the policies. So you will go to the security policy. Here you will see that we have these by default two rules available, intrazone and interzone. So intrazone means if trust would like to communicate to trust, that is allowed, that communication is allowed. If untrust wants to communicate with untrust, allowed. DMZ wants to communicate with DMZ, allowed. But if trust wants to communicate with untrust or DMZ, that interzone by default it is deny, right? So it means we need to create a rule to allow the communication. So we'll create the rule and we will give it a name internet access and source. So my source zone is going to be the trust. My traffic will be coming from the trust. Source address is going to be 10.2.2.0/24. This is the subnet. So if it is not defined, then you can click on addresses. You can give it a name, LAN subnet, right? And you can just select IP range, wildcard, FQD, and IP net mask. And then we can define our subnet 2.2.0/24. And if you want to add any tag, you can add, right? So I'll let you know what are these tags and all that later on. So click OK. So LAN segment, LAN subnet, then source user if you have user ID configure, so you can bring the users, I mean you can create the user level rules as well. And source device if you have HIP profile configure, so you can tag the device as well. So this rule will be applicable to that user and to that particular device. Then destination is going to be the uh, untrust, that is my internet, and destination address could be anything, any device, right? Now comes the application. So application could be anything, or you can call the destination applications, what type of access you need to allow to your users. So since this is going to be the basic internet rule, so we are opening everything as of today. So we are keeping it any. Then service category, URL category, it is like any, or you can keep it application default. Now actions, so action is allow. You get all these options. So right now we are keeping it allow. And profile setting, these are my layer 7 profiles. Where you get antivirus, vulnerability, anti-spyware, URL filtering, file blocking, and all that. So right now we are just keeping it none. We will check it out later on in depth how to configure these profiles and get the granular control on the user traffic. Then logging setting. So log at session start, log at session end. So we generally do log at session end so that we can get the complete details of the session. And then you can also configure the log forwarding profile if you have any, syslog server or any log listener is available in your network. So you can configure that. But right now we're just keeping it none. Okay. And you can also create the schedule when you want to when you want this rule to be active or deactivated, and if you need to have any QoS, right? So you can do that. And if you want to disable the server response inspection, that service can also, I mean, that can be also done. So it's okay, right? Now we need the network address translation. Why do we need that? So although this is private, but the firewall which is present or which is acting as a gateway for this particular topology, that is expecting traffic from 10.1.1.3 IP address. So if I'm going to send the traffic from 10.2.2.7, which is my PC's IP address, this IP address right here, so internet will not work, right? Why I have done this? So that you can get the real feel of production environment, because I told you before as well that we are going to configure the public IP address on these interfaces, right? On outside interfaces. And whatever traffic we receive from the LAN interface, we do NAT, network address translation, so that it can communicate to internet. So in LAN, we configure private subnets. In WAN, we have public subnets, right? So just to give you that feel of the production environment, I have done this. So now what we need to do is we need to create the network address translation. So we will go with PAT, port address translation, which means that entire subnet will be natted on a single IP address. So we will click on add. We will give it the name internet access, And if you need to add description, tags, NAT type, so this is IPv4, right? NAT 64, NPTV6 is also there. So right now we are doing IPv4 NAT. Then original packet will be coming from trust. Destination zone, it will be going to untrust. Destination interface is going to be Ethernet one by one. Service could be any. My source address is going to be the LAN subnet, and my destination address is going to be anything. So this is the real packet which is going to hit this particular interface, right? Now we need to do the translation. So your translated packet, how it is going to look like. So whether you need to do source address translation or you need to do destination address translation. So we will do the source address translation, which means that source IP address will get NATed, destination will remain same. So let's say if take it like this, if 10.2.2.7 would like to communicate to 8.8.8, so source translation means this IP will be translated to something else. In our case, it will be translated to this IP. Okay, and then it will go. So destination IP will remain same. So if I talk about your source socket and destination socket, because in layer 3 header, that is our IP header, we have source IP details, we have destination IP details. And in layer 4 address, we have port, source port and destination port details. So when you combine that, source IP plus source port, so it is called source socket, and destination IP, destination port, destination socket. Okay, so initially your source socket will be 10.2.2.7 and service port will be, source port will be any random, and your destination socket will be 8.8.8, and let's say we are connecting on port 80, right? After NAT, it will look like this: 1.1 10.1.1.3, and it will randomize the port, whatever port is free. Let's say 4, 5, 6, 7 port is free, and this destination socket will remain same. So this is port address translation, PAT. In most of the scenarios, you will see implementations like this only. So we will see dynamic IP and port. So whatever IP or port available, just select it. Address type, translated address or interface address. So we will go with the interface, select the interface, select the IP address. Okay, click OK. So now basic configuration is in place. Let's do the commit. So when you click on commit, there are two options: commit all changes, commit changes made by the user. So if you do commit all changes, and if your administrator is having the rights to commit on behalf of other administrators also, then all the changes will be pushed, right? So generally in assurance, I mean, in day two activities where you're providing support, right, and the network is already live, in that case, whenever you make any change, you know, or whenever you implement any change request, you have to be very, you know, cautious. I would say that you need to take precautions. Whatever you are committing to the device, you need to make sure that only your changes are going to hit the device, right? So basically, whatever changes we have made before commit, we have not committed anything. So right now, whatever changes we have made it inside the candidate configuration. Okay, when you click commit, it goes to the running configuration. So basically, in Palo Alto firewall, we have two types of configuration. One is candidate config file, another one is running config. So whenever whatever changes you make through GUI or SSH, first candidate config template gets modified, and when you do commit, it updates your running configuration. So basically your running configuration is running in the data plane of the firewall. So this firewall is having two planes, management plane and data plane. So data plane is processing your production traffic and management plane is taking care of your management related traffic. So if you go to commit, if you click on preview changes, you will be able to see what changes have been made in the candidate config, and if you do commit, what will be modified. So you can see this was not there, this was not there, and these are the changes which have been made. So you can validate the changes and then only you can commit. You can also see the change summary, what has been modified, owner, all the things. And if you can also validate the commits, directly commit will like it will first validate and then push it to data plane. But if you want to validate that whatever you have done, it is correct, so you can validate the commit before pushing. And once it is validated, you can then push it to the device. But we are going straight forward with the commit. So then it will, first start the validation process. So basically what happens when you do the commit, there are three phases: phase 0, phase 1, and phase 2. In phase 0, it creates the object IDs. So once those IDs are created, then your commit process enters into phase 1. In phase 1, it does the validation with all the daemons running. So daemons are nothing but the background processes which are running in your firewall, right? So it will do the basic validation on those daemons. Let's say route D is the daemon which is taking care of your routing engine. Similarly, we have different daemons: dev server, management server, right? So once all the validation is done on those daemons, then it enters into phase 2. And once the commit enters into phase 2, it will never fail. So if your commit is going to fail, it will either fail in phase 0 or it will fail in phase 1. It never fails if it enters phase 2. Okay, so now you can see it is almost going to commit. So 99% is like almost done. So let's go back to our PC and let's try to first ping the gateway, whether we are able to ping the gateway. So now you can see we are able to ping the gateway, and now let's try to ping internet and see if we are able to communicate. So now you can see it is timing out, but now we are able to communicate, right? And let's verify whether we are able to open up the websites or not. And meanwhile, if you go back to your firewall, you can see commit completed successful. And if you go to policy, security policy, you will be able to see the hit counts. So whatever rule you have created, it will give you the hit counts. If that is taking hit, so you will be able to see the hit counts, right? And you can also reset these hit counts, to make it zero anytime. And once this is reset, then you can refresh it and you can check, whether it is taking hit, because sometimes it happens that you have created the rule but it is not taking hit, and you need to reset this counter, and then you need to just keep on refreshing to see whether it is taking hit or not, right? And it is going to tell you last hit, first hit, your rule usage, right? When it is modified, when it is created. And similarly, you can go and check whether your NAT statement is taking hit, because generally the problem with internet traffic is NAT, So source-based translation is easy, but when we have scenarios for destination-based translations, we see problems, right? So you can see hit counts. Okay, so everything is working properly, and if I will open up cisco.com, so let's see how it goes. And in fact, here you can also check if DNS is getting resolved. So ns lookup cisco.com. So DNS is timing out because we have not configured the DNS. It is using the internal DNS, and this internal DNS is not ready. So that's the reason it is timing out. So let's do one thing. Let's go ahead and define the public DNS so that we can open up the cisco.com and other browsing stuff. So you go to properties, IPv4, and then you define the DNS to be 8.8.8.8, and my secondary DNS is going to be this. Okay, close, bingo. So now if you do this, so we are able to resolve the IP. Now resolve the domain name. So now you will see that Cisco page will come up, and similarly you can open up other website. So this machine is like, virtual machine running in a virtual machine. So basically it's like I have a bare metal VMware server on which EVE-NG is hosted, and inside EVE-NG this virtual topology has been built. So now you can imagine the level of virtualization we can do these days, right? So slowness is expected. So you can see we are able to open this website, and similarly let's verify the logs. So if you want to verify the logs, you can go to monitor, and inside monitor tab you can go to this traffic log, and you will be able to see that these are the logs with timestamp. So if you apply filter like I need to see source IP address is this, right? So just do apply filter, and it will filter out your logs basis on the IP address. And if you want to filter it out basis on destination, so source is this, destination is this, then you can apply the filter, and it will only show you the connection with this particular source and destination addresses. So rest of the traffic will be filtered. So basically 72.163 belongs to cisco.com. And if you see, so incomplete, trust to untrust, we are not decrypting the session, right? Which rule is taking hit, why session has been ended, okay? And you will be able to see more sessions. So port AD 443, right? So these are the sessions which we are building. And if you remember in the log settings, we have configured that we have to log at session end. Similarly, if you go to session browser, you will be able to see that what are the current sessions which are active. So you can see these are the current sessions which are active from this particular zone to this particular zone. This is the source IP, destination IP, source port, destination port, protocol, application, and which rule is allowing that particular connection. So you can see all these sessions are active, right? Similarly, you can verify this from the this particular machine as well, the CLI of the firewall. So let me log in into it. dc1.cybersec.local, and username is going to be, let's connect, then we will add the username. So username, password, and access denied. Let me enter the password again. These are the best tools available for your day-to-day jobs, right? So you can see now we have logged in into the firewall. Okay, so we are inside the firewall. Now you can just check the current sessions, show session all. It is going to give you the details of your active sessions. So vsys, vsystem ID, which particular vsystem this particular session is active, your application, your state, session state, active, discard, type, flags. So these details I have already covered in our advanced course. So if you want to learn these things in more detail, So you can enroll to that advanced course. It has more granular detail so that you can become the TAC expert. Then source IP, source port, zone, protocol, translated IP, translated port, destination IP, destination port, zone, translated IP, and port. So this is the source IP, source port, source zone, protocol. TCP is represented by protocol number 6. Destination IP, destination port, and zone. And now you see the translation. So your source IP is getting translated. It means we are doing source NAT, right? And then you can see your destination IP. It is not getting translated. It means we are only doing the source NAT. If you want to see more details about it, so you need to just type show session, you know, and then you can select type ID and then just select this, and you will be able to see the details of the session. So in Palo Alto Firewall, each connection maintains two flows: client to server flow, server to client flow. So client to server packets will be captured in this particular flow. Server to client packets will be captured in this particular flow. So you can see, and then start time, timeout, total byte counts, you know, all the details, which rule is taking hit, what is the VSys name, application, and NAT rule. Okay. Layer 7 processing is completed or it is under inspection. Ingress interface, egress interface, all these details you can see, right? Same details can be seen here as well. So if you click on plus icon, you will be able to see all these details. And similarly, if you go to traffic and if you click on magnifier glass, you will be able to see more details. So if you click here, it will give you the more details: session ID, what was the action source from policy, application type, rule UUID, session end reason, category, all these details you get here: source user, source IP address, country, port number, zone, interface, NAT IP, NAT port, all these details you get from here. Okay. So that's it in this lecture. In coming video, we will see more details, more basic configuration like user provisioning, how to add the administrators, how to configure the profiles for the administrators, right? How we can create the local users, how we can onboard the users from the Active Directory or any other stuff like that. Okay. So thanks for watching this video. Have a nice day.